So this video is really intended to talk about a lot of the exponent and radical properties, and you've probably learned some of these in previous classes, but I want to make sure that you have them all in one place because you'll be required to use them and utilize them throughout this course. So we talked in class a little bit about the definition of what it means to be a radical, and we've got two radicals here, right? This is a more simple version where the radicand becomes the denominator for the exponent fraction. So if there's a third root, here we'll do an example. So if we're talking about a third root, if we're doing like the third root of x, that becomes x to the power of 1/3. And here's the property, and here's an example. So I'll try and give an example for each problem that we do. Similarly, we talked in class that if I have an exponent on the thing that it's inside the radical, that becomes the numerator of the exponent. So here's a quick example. If I have, the third root of x to the 7th, right, that becomes x to the power of 7 over 3. And now if you're a little bit puzzled by this, take a moment to compare where the m and the n go to in the second example. So these are just two of the properties that we're really going to be talking about today. And so on your paper, I really think that it is to your benefit to have the definition and an example so that you can refer back to them. In fact, I'm going to name these the definition of a rational exponent. Of a rational means fraction, exponent. And one is more simple and one is more complicated, so I made two of them. We're going to go through about 9 in total, including these two. And so I really want you to have this on your paper kind of organized in this way. I'll try and give it a name, a property with letters, and then a property with an example. So we're going to start here with the product of powers. And through the magic of this video editing, I can just write stuff, so I'll do that throughout this video. So we've got the product of powers. You've seen this before, and it says this, that a to the n times a to the m is a to the n plus m. And you probably learned this earlier in previous math courses, and it's really just saying, hey, I can add exponents when the base is the same. And so I'll give you a quick example. If I have like 2 to the third times 2 to the second, that is the same as saying, hey, this is 2 times 2 times 2 times 2 times 2. So that's 2 to the power of 5. So our next one is gonna be the quotient of powers. And you've seen this one before as well. The quotient of powers says a to the m divided by a to the n is a to the m minus n. So I'm taking the exponent of the numerator and I'm subtracting the exponent from the denominator. And this only works because the bases are the same. They're both at a. So I'll do another example, kind of like we did before. And I'm going to choose really strategically, right? So I'm going to choose something a little bit different and unusual. So I'm going to say a to the third. Ooh, let me change back to white. A to the third power divided by a to the fourth power, well, it's going to be a to the 3 minus 4, so that's going to be a to the negative 1 power. We're going to talk about what happens when I have a negative exponent in just a moment, but I want to expose that idea to you, that I could have this negative exponent. It doesn't mean that it's negative. It really means that, like, if I had 3 a's up here, that they'd cancel out mostly. We'll talk about it in a moment as we get to it. So the next one is a power to a power, and I'm sure you've seen this one before. And what it says is a to the m to the power of n is a to the m times n. Those exponents can multiply. And by the way, these properties work forward and backward. So if I see something that I could divide, I could split it up kind of in the same way. So here's an example, and it's a kind of an interesting example. Here we go. 7 to the third to the power of 2/3. Ooh, that's kind of interesting. So I can say, hey, that's really 3 times 2/3. So that's 7 to the second power, because the 3 and the 2/3, the denominator and the numerator there with rational functions, they cancel out. So our answer is 7 to the power of 2. Our next one is going to be a power of a product. And this is a handy way of simplifying things that you need to just maybe distribute. It's almost like the distribution of an exponent. But with exponents, because everything's multiplication, we got to be really careful that we can't distribute over addition. It has to be through multiplication. So I'll show you. And what this says is that if I have two numbers multiplied together, a and b, and they're both being raised to the power of some number, m, then I can distribute that, right? A to the m times b to the m. That m goes to both the a and the b. And what that looks like is, if I do like, well, you can verify this. I'm choosing numbers that you can verify. 2 times 3 to the power of 2. We know that 6 squared is going to be 36, right? So that is the same as saying 2 squared times 3 squared. And you could verify this, right? This is 6 squared, which is 36, right? And this is 4 times 9, and 4 times 9 is, by the way, 36, right? So these properties hold. I'll erase this stuff because, that's not my eraser. I'll erase some of this stuff because I really want you to think about, maybe it won't let me. I really want you to think about, hey, like, what is this property that we're really addressing here? And so I'll put a big box around the thing that I think is the most important thing. All right, we've got a couple of extras, and this is where we're going to talk about those negative exponents and what the negative exponent means, right? What is this negative exponent? And I want to be really clear. Negative exponents do not mean that they are negative. And so there's really kind of two ways to represent them. If I have a to the power of negative, let's say negative m, we could rewrite that as 1 over a to the m, right? The function itself is still positive. It's just representing that, hey, this is really a fraction. And I hope that you can kind of maybe go back up here and notice that if I delete 3 of the m's, this is going to be 1 over a. So a to the negative 1 is representing 1 over a. And let's use this negative exponent property. It's representing 1 over a. It's not negative 1 over a, it's 1 over a. It doesn't make it negative. It doesn't change the sign. The negative simply represents that it changes to a fraction. I know that I'm harping on this because it is that important, right? And negative exponents, if they're on the denominator, let's say I do like 1 over, b to the like negative 2, well, that can come up to the numerator as b to the second. And so here's a really good example, and I'll try and choose really simple numbers for our example here. If I do 2 to the negative 1, that represents 1 over 2, and I'll do a second one. If I do 3 to the negative second power, that is 1 over 3 squared, which is 1/9, right? Because 3 times 3 is 9. So a couple of ways of representing these. I know that these get a little bit tricky. We've got 2 more, and then we'll be good to go. I hope this negative exponent thing really clicks for you. Now, with radicals are just exponents, right? If I have a third root, that's really like saying a to the 1/3. It's going back up to the very, very top of this thing and saying, hey, if I think of my radical function as an exponent, I get to use all of these radical exponent properties. So really, we can start using some of them. And I want to expose these to you because I think they're really powerful. So I'll just make them appear here really quickly. All right, so what is this really saying here? This is saying that I've got a times b to the power of 1 over n, because that's one of our properties from up above. And what this says is saying, hey, like I can use the power of a product right up here, right? If I have something that's an exponent, it can be distributed inside. So let's go ahead and do that here. So this is saying, hey, this is really a to the 1 over n times b to the 1 over n. And so maybe we'll find this advantageous. And we can kind of go backwards and we can say, hey, like a to the 1 over n is the nth root of a, and b to the power of 1 over n is really, so multiplied by the nth root of b. Now, I know that these are just letters, and right, in one of these 3 forms, or 4 forms might be really advantageous to us. We might find an advantage to writing that in one of those 4 ways. And so this is our product property of radicals. And sometimes we can just jump from here to here. If you recognize the property, you can go from here to here, right? So there's a lot of ways to kind of orient yourself in this map. You can kind of jump between these 4. But I hope that you can see that like you can essentially rewrite this as 2 radicals, which is really, really helpful sometimes, right? We got one last property. It's our quotient property, which says that if I have the nth root of a over b, we'll do the quotient part, so that was the product part multiplying, this is the quotient part. We can kind of do the same thing. We can say the nth root of a over the nth root of b. And, right, what does that say? That's saying that that's a to the 1 over n divided by b to the 1 over n. And, right, we can say that in total, right, like, that's a to the a over b to the 1/nth, right? We're not using the quotient property here because a and b are different. So this is kind of like reverse distribution, but for division. Right, so we've got a total of properties here. I hope that you find this useful. I like to have these listed next to me because I think that oftentimes there's so many things happening that sometimes you just need a reference for like, what can I do? What exponent properties are available to me? And now that we're throwing fraction exponents and negative exponents in there, it can get jumbled up really quickly. So I hope this video is helpful. Thanks so much for watching.